Boom. 7, 13, 63. That's what we have for our homework questions for 7-1. Any others? Jam. Okay, going once, going twice. So good. None. All right. Number 7. Let's jam with that one here. Did we do 13?
Yeah. Yeah.
Yeah, we did. I don't know what it is. 13.
X minus y is equal to -4.
Oh, I like this.
X squared minus y is equal to -2. This is number 7 running across. Let me do this one real quickly here. So you guys tell me here, a solve for the top X, top Y, bottom Y. Which one? Top Y. Okay, that's the consensus of the group. So I'm going to subtract X from both sides. -y is equal to -x minus 4. Divide through by -1 everywhere, and voila, we're good. X plus we could add y. That's fine too. We could have add y, and it would be y minus 4. That's fine too. Absolutely, no problem. You do have to. If you do it that way, then you have to FOIL x squared, then right? Because you're going to have y minus 4 to the y minus 4. Sure. Abby, just make sure. If you solve for x first, right here, then you would have plugged.
So she solved for x
and then
first.
add 4, and then you get y equals, just so we don't have to do the multiply by negative thing, that's all.
Oh, gotcha. Okay. Understanding. Yes, you can.
Okay.
If you- Gotcha. You do have the option of solve for x. Let me show you at least that here. So if you did that, then you would have had an equation that looked like this, though, and you'd have to solve. So a little bit more complicated. You can still do it. Absolutely, you can still do it here. So go backwards, and I'm going to go plug this guy into here. So I have x squared minus y becomes x plus 4 is equal to -2. Distribute the minus sign to both sides. I'm going to add 2 to both sides. Tell me if you guys are good still there. There you go. Okay, and then we have ourselves a -2, +1 for our factors. Therefore, we have a +2 -1 for our. And if you look at the graph, that's why they give you the graph, just so you can kind of see the graph and see the solution set. Absolutely, there it is. -1 is where they crosses, and 2 is where they cross the parabola. Solve the system by the method. Okay, so then we have to plug in the x equals 2. Plugged into this guy now. So 2 plus 4 is 6. I have myself a 2 6. Plug it in a -1 into here. -1 plus 4 is 3. So voila. How about a -1, 3? Done. We're good. And it should be exactly, you should see the intersection points on the graph for number 7. Okay, good there. Going once, going twice. Just going as quickly as I can, but you guys slow me down if need be. 13. All right, now we have no linear factors whatsoever. This is just this graph with this graph. Not fun, not fun. Let me show you the graph of the book though. Graph of the book goes like this. Ooh, let me see this intersection. That's a cubic. Oh, where's my cubic? Sorry, that's my cubic right here. That's a 3. That's my cubic equation right there. My. Oh, okay. So let's see what happened here. I got this intersection point from the graph itself. Coming down, I have another one right here. And then as this guy turns, it gets another one right here. That'll be interesting. Cool. So you know from the graph, it's going to hit 1, 2, 3 times. Let's see what we can do. Oh, look at this. Y is equal to this one. Y is equal to this one. Perfecto. First equation is equal to the second equation. They're both equal to y, so they're both solved for already. Awesome. So then I got myself, let's see, first things first, that one and that one can just cancel off. Is that right? Okay, so now I have x cubed minus x. Let me go kind of slowly just to make sure we got everything here. Yep, I'm gonna subtract x squared and add 3x at the same time. Subtract x squared, add 3x. So I wanted it to go to 0 because I need a factor. And I can only factor if it's set equal to 0. Plus 3x, everybody good there so far? Okay, now you guys talk to me. What should we do? Factor out the x, absolutely. X gets to go out. I'm left with x squared minus 4x plus 3. Ooh, now we're down to quadratic. So can you guys factor that?
X minus 3 and x minus 1.
X minus 3, x minus 1, perfect. All right, those are my factors. Therefore, my solution sets are x equals 0, x equals 1, x equals 3 if we want to write them in order. And the graph, absolutely, there it is. That's 1. 2 is like right here, and 3 is right here. 0's there. So we do have to plug in x equals 0 into our one of the graphs, doesn't matter which one. Both of them are going to give us 1, aren't they? Because all the x's canceled. That little extra 1 right at the end, because they're both talking about the y-intercept. So that becomes 1, so 0, 1. X is equal to 1. That's pretty easy to plug into as well. Notice, interesting, if you were to plug in a 1, 1 here or a 1, 1 there, the computation is exactly the same, right? Because when you cube a 1 or square 1, still get 1. All right, I'm thinking what, -2 right there, or what, or -1? -1, okay. All right, this one, the 3, and I probably would plug into the bottom one. I don't have to deal with cubes on my hands. I can deal with the 9 easily. 3 times 3 is 9, minus 3 times 3 is 9. Oh yeah, like that. Just a 1. So how about 3, 1? Sounds great. That's what Tony the Tiger says. Before your time, Tony the Tiger? Let's see. That's because Joe watches YouTube videos. That's why. Frosted Flakes, yes.
Whenever I think of Tiger, I think of Mr. Rogers' neighborhood. So then I just like, did he say that?
Hawken, which one were you missing? Which one did you not have?
I like to think about
I think I didn't have one negative.
Once the added years, it
One
was like,
negative.
Because I did it differently. I didn't get it all on one side. I think right after you added subtracted 1 from both sides.
Right here.
X cubed minus 2x squared equals x squared minus 3x.
Mhm.
I factored out an x squared from the left side and an x from the right side.
Oh, gotcha. Okay.
Yeah.
Got it. Okay. So yeah. So the lesson here is before we start factoring, that little guy is the special guy. We have to set it equal to 0 before factoring anytime. Reason for it is because of this row hook here. 5 times what gives you 0? No way. Awesomeness. Actually, no, let's see. I should do it this way here, actually. That's what we need to do. So I got 2 numbers, right? If I have 2 numbers that multiply equals 0, I know that one of these guys has to be 0 or both, right? But if I look at like 24, let's say, right? So this guy is very limiting. 24, a whole bunch of stuff, right? It's not limited. Right? In this case, I know that. I know at least one of them, then I know the other one. This one, there's an infinite amount of solutions to give me 24. Good there. So it's that 0 that actually binds it to something. So, okay, we can factor now. Okay, 63. Small software company invests $16,000 to produce a software package that will sell for $55.95. Each unit sold each unit can be produced for $35.45. Okay, how many units must be sold to break even? And we have some number crunchers in the room as well that did it last time just by number crunching. That's cool. We have cost equation and revenue equation. So the cost equation here, they invest $16,000 initially. And then also it takes $35.45 to make each unit. So in this case, that's going to be our X. So there's your cost equation real quick. And cost equations in normal business here, they usually string out to the cubic formula. So this one, then you'll usually have an X squared, X cubed still. Because costs usually fluctuate based upon the quantity that you make, raw material costs, supply and demand curves. Revenue is going to be exactly 55.95 per item sold. So break-even point is right there. When is that equal to that? Or you can switch it around, right? We can do the other way here, right? When is that equal to that? But we have ourselves 16,000 plus 35.45 to 55.95. And this one, notice there's no X squareds in here, right? This is just a regular old linear equation to solve. 2050, is that right? I think, yeah. And then probably need a calculator here. How many times does $20.50 go into $16,000? Say again. 781 units sold. Okay. That's part A. Part B says, how many units must be sold to make a profit of $60,000? Now, profit, well, I don't know if we talked about this one. The profit equation is this right here. It's revenue minus cost. I think we did that, right? So you sold for this much, but it costs you this much to make it. So eventually profit is the difference between the two. And you'll notice that there's some similarities right here because you go profit is equal to 55.95x minus 16,000. I'm going to write a little smaller here to fit it in. 35.45. Oh, sorry, it's a plus. Sorry, plus sign right here, minus sign here. And you'll notice the profit function is actually $20,000, sorry, $20.50 minus the 16,000. Hey, there's some similarities here. So revenue, as far as revenue is concerned, each time you sell a product or make one and sell it, right, you're going to get 20 bucks in profit. So now the question is, when will we make 60 grand? Ooh, awesome. 76,000. You have to bridge the gap of how much you want and then how much it costs you. And 20,050. Sorry, I heard the answer. Answer is 708. Yeah. Boom. There it is. Again, does it get more complicated? Absolutely, especially when you have distribution costs, employee salaries, everything else in between.
I did this a weird way and still got it right. I
Cool.
did the revenue after breaking even would be $20.50 per package. So I did 60,000 divided by that equals 2,926.8. And then I added the amount of units you would need to break even.
Sweet, perfect. That is really good. Very thoughtful. Into that, exactly perfect to do that. Because you figure you already know how much it makes to make zero. Then you just need to know how much it makes to make that one. And it's essentially, you did this right here.
Oh,
right? And then you add it to how much it takes to give you the 16.
oh, I see, okay.
So perfect. Okay, cool. We'll add that at the end. Let's jam with 7.2. Let's see, we have how many minutes? 25 minutes? I think we can do it in 25 minutes.
That is-
So last time we did linear, look at that, linear and non-linear systems. So now we have cubes in there, we have quadratics in there. So we're gonna go back really quick here. We're gonna go back to linear systems for 2 times here. So 2 variable linear systems. And this stuff you probably know from Algebra 1, but we'll kind of review it. You guys tell me thumbs up if you know it, thumbs down. Thumbs up if you know it, I'll give you more challenging problems. Thumbs down, I'll give you less challenging problems. So we'll see. Okay, and then 3.7.3 is the toughie. Usually it's what happens instead of having 2 variables, what happens if we have 3 variables? Should we make 4 variables? Should we make 5 variables?
Thank you.
Yeah, come on. All right, let's go with it here. So we're gonna go through back to the elimination method, right? We did substitutional this time in 7.1, right? But the easy ones are solved by the elimination method. That's the one. So let's go back real quick here, just in our minds here, right? This one we concentrated on this one was the substitution method. Substitution method was 7.1. These 2 here, we're going to concentrate on the elimination method. That's what we're practicing. All right, let's jam. All yours there, write it down. And these guys are going to be simple. I think you guys can remember this from Algebra 1. Like, oh yeah, I got this. I remember this stuff. All right, this is also the way calculator systems, if you plug it into calculator, this is also the way it works as well. It does this sort of form of elimination method here. All right, and then tell me if you can't see, because I can always zoom in real quickly here. Okay, and if you can stay ahead of me, go for it. And anybody remember what to do from algebra? So good. Add them up, absolutely. We add these guys up. We did that on the first one for 7.1, right? That was on like Monday's class. Cool. If we add these guys together, we get a 3 and a 5 make an 8x. And then what we're shooting for is those y values to go away. And then we get ourselves 12, is that right? Oh, no fun. We get fractions here, or we get decimal answers. That's no fun. Let's see, by 4, maybe, divide by 4. 3 over 2. So what do you guys say, 1.5, was that about right? Okay, cool, 1.5. Here's the thing, we gotta plug it back in and see what we get for the y value. All right, decimals, you can keep it in decimals. If you want to put it into, just keep it as 3 halves, up to you. We're good? Actually, just raise your hands here. How many would rather keep it as 3 halves and plug in the fraction back in? Cool. How many would rather keep it as 1.5 and plug in a decimal and be done? Oh, okay. I'm going to choose the top equation. Sorry, Elka, I'm gonna have to go with the majority of the class here, even though I prefer your method anyways.
I'll forgive you. The rest of the people.
3 times 1 is 4.5. Oh, no fun, huh? Because if we did fractions here, we actually would have what we need. Let's do both ways. Just negative 0.5, is that right? Trying to convince the room that your way is better.
My way probably isn't better. I just like doing less work.
Oh boy, we have a negative 0.5 over 2. How fun is that? So that means this is a negative what? Negative 1/2 divided by 2, is that right? Oh,
So maybe 1/4.
negative 1/2 times 1/2 makes a negative 1/4 is the final answer. So 1.5, negative 1/4. Look at that, a decimal and a fraction answer. No
Love
fun.
that.
Okay, how about if we did it Elka's method? I would have plugged in a 3/2. That becomes 9 over 2. Good there. Why is that a little simpler? Because what we're gonna do is we're just gonna multiply through by the denominator. So I'm gonna multiply everything through by 2. And I don't have to deal with fractions. So 2 into here, the 2's cancel, leaving us with 9. That makes a 4, and that makes an 8. Love it. Okay, just by multiplying through by the denominator, the common denominator sometimes, I don't have to mess with the fraction until this little divide part right here, and I'm done. Okay, both answers are, oh, negative. Both answers are totally correct. We're good. Okay, what do you guys say? Easy or difficult or medium? Okay. Easy. Luke, did you say easy? Oh, awesome. Luke, we have a problem just for Luke right over here.
Why would you do this?
We have find the value of k such as the linear systems has no solutions. Now, we're not going to do this one. This problem is just for Luke only. Right there. That's just for Luke.
Very good.
All right, Luke, you got it. Well, you said it was easy, so surely you should be able to do this easy.
Well, I don't know about that. I know that I did definitely use a. Maybe I didn't.
Cool. Hawken, just come back for you here real quick. Are you okay? This one, what we did is we just did the regular elimination. We add them up. And we divided by that. It gave us a fraction answer, a decimal. So we plugged in both just to sort of see what happens here. And we got ourselves an answer afterwards. So that was the easy one, basic one. We'll move on to more difficult ones in just a second here. Luke gets this one. And then the rest of the class gets this one.
Oh, perfect. I was trying to do a Luke one.
Should call it a Luke problem. Okay, guys, real quick here. So on the first one, notice we had that 2y minus 2y. That was easy. Add them up. We're done. You guys talk to me here. What happens if we don't have opposites? We're sad at first, yes.
We have to do substitution.
Oh, we could do substitution. That'd be fine. Notice if we were to take the bottom y, we subtract 3x from both sides, we can do substitution. But we're trying to work with elimination. So we're going to use a multiplication in order to get opposites. So I'm thinking to myself, 2 and 3. Oh, Luke problem, back to Luke. 2 and 3, I'm thinking if I get a 3 right here, that would have been awesome because that would have had opposites right there, huh? So here's what I'm going to do. I'm going to multiply. Here's the way we show it. I'm going to multiply this bottom equation by 3. And then if you want to kind of deal with it, you can just say NC, this is called no change. So by multiplying through a equal sign, right, we still keep the, is that true, guys, real quick here, if we think about it here? If I have this like this, if I have 2x is equal to 5, right? Let me do it even better. 2x is equal to 8, right? If I were to multiply both sides by 3, right, is that still the same equation? Would I still get the same answer? Yeah, this is our multiplication rule. In fact, we go the opposite way usually, right? We divide through, right? Usually do a divide rule, but technically it's still multiply. Okay, crazy idea. You guys ready for this? In pure mathematics, there's no such thing as subtraction. There's no such thing as division.
So do you just add negatives and multiply by what?
Absolutely. So here, instead of dividing by 2, you would be a multiplier by 1/2.
How does that make things easy?
In abstract mathematics, super easy.
Oh,
Because then you have 2 operations and then you don't have 4 operations and then you do the same thing. Kind of. Okay. Anybody done yet?
Negative 2.
Yeah, fractions, yeah. So everything gets multiplied by 3, so that 3x becomes a 9x. The y becomes a 3y as planned, and this guy becomes a -15. Are we good? Yes, awesome. Keep on going. I got myself an 11x. That's gone. And -22. So x has to be awesome. Plug back in. Oh man, we have lots of choices, guys. We can plug into the top original, bottom original, the top the same, or the bottom multiplied. Who cares? Doesn't matter.
And that equals 1.
Okay.
Crazy.
Top original, bottom original.
Yeah.
-6, is that right? At 6. Done. X goes first, Y goes second, done. Of course, those are still easy. Say again? There, oh yeah, Luke, did you get this one yet?
How's it going?
Did you copy down the problem?
No.
Oh, that's why.
well, that might explain some things.
Oh, obviously that's the reason.
Uh-huh. Okay, next one, more problem. Now, instead of having a -y by itself, we could multiply by 3. That would have been easy. Now we have a 4y. Not good, not good. Okay, any ideas? What should we do?
Multiply it by a common denominator, so then you just do multiply both of them. Multiply the bottom one by 3, multiply the top one by 4.
Okay, yeah, so we can multiply each of these guys by different numbers, because remember the last one we multiplied by 3, but the top we left the same, right? So the multiplication of a common number just means that we're going to do it both on left and right side. Are we good? Okay. And Elika says multiply here by 4 and here by 3. How come? Yeah, we're not trying to look for lowest common denominator. We're just trying to look for opposite numbers. That's all. So I'm thinking to myself, we have to sort of plan ahead here. So I'm thinking if this guy's going to be a 3 times 4 is 12y, a -4 times 3 makes it -12y. Or an opposite number. I guess we should say opposite number. 8.
Yeah,
Just kidding, look at 6. All right, jamming here. So I'm gonna try to get ahead of you guys here. So da-da, 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 da-da. Oh yeah. Anybody 14 times 3? 42, thank you. No problem. We're on example 3. In general, this is called elimination method. We're just practicing with that. I think you probably should remember. You guys say the y's canceled, yes? 80, is it 88? Is that right? 78, okay. Awesome. Oh, boy. Does it go in even amount of times? Oh,
Yeah, it's 3.
3. Oh, cool. That's awesome. Whoa.
Totally calculated that by myself, not with the. Oh, no.
also, I'm just impressed that I could be 14 times 3.
I know, I thank you for that.
It's like the high point of that.
Yeah. I went to mine after today was when I woke up and I took the time and I was like, oh, that says 6:30. It's time to.
Okay, we're good there. Quick question to you guys. Could we have gotten rid of the x's if we wanted to?
Yes.
Aw,
Why would we want?
It's more trouble than
It's
it's
more
worth.
trouble. I
And then you have to
know.
subtract, and then you have to subtract in negatives, and that's adding.
Why?
I-
Too much work.
No,
I don't wanna do that.
Bottom one's smaller.
Okay, I'm gonna do it, so you guys don't have to.
Thank you.
So I'm gonna multiply the top by a 2 to make a 10x, is that right? I'm gonna multiply the bottom by a -5 to make a -10x, we're good? So my piece is just multiplying through. I could have multiplied the top by -2 and the bottom by 5, right? It doesn't matter, as long as I got those opposites. I just wanna see if I get the same thing here real quick here. 10x, was it 6y, 18? This is gonna be a -10x. This will be a positive 20y, is that right? And then what's that?
15 times -5. Abby, no. Well, 4 times 5 is 20, so then you
Negative
get 70.
-70, okay. Okay, adding up. Now the x's are gone. This is 26, that's funny. 26y. And this is
Negative.
-52 divided by 26. Yeah, that's right. Look at this. Notice that y is the same y that we got down here. So
Just 2 divided by 26. Just- so. That's like the worst pronunciation I've heard ever. Well, that's not even my name, so that's not bad pronunciation. That's just straight up. That's just straight up wrong.
okay, are we good, guys? So we're able to multiply either one number as long as we can multiply through by negative to get. So real quick, if this was a positive right here, instead of a negative originally, then we would have had to multiply by one of them to be negative, right? That's the only way we can create opposites to be there. So maybe something like that on the homework somewhere, sometime. Ah.
There's not.
Okay, the other thing is,
Sadness.
yeah, that's right. Do you guys remember this from algebra? Okay,
Totally. I don't remember anything from else.
so you guys talk to me here then. Is this a linear equation? Oh yeah, is this a linear equation?
Yeah.
So really what this means is I have two lines. 1, 2, 3, 1, 2, 2 lines. One coming down maybe like this, another one coming down or going like this. And where's the intersection point?
3,
3, -2. Okay, so now the question is this. If I have two lines on a plane, what are the different possibilities of them intersecting or not intersecting? Talk to me.
This one is 100% that it's gonna intersect.
Oh yeah, this is one intersection point, or maybe we can say one solution. We're good.
When you do both straight lines, there's no where they're gonna intersect.
Oh, cool. Okay, Noah says this. The other option is they could be going like this. They're just right next to each other. What are those called, anybody?
Parallel.
Parallel lines. How many solutions? 0. So no solution or 0 solutions. That's cool. So I got one solution, they interact. No solution, they're parallel. One more possibility.
That's a problem.
No, just lines in general, only lines. One more
They're
possibility.
on the exact same point, so they touch the entire time.
Oh yeah, so the other possibility is one line is like this, but the next line is different equations, but when you start graphing them, they're right on top. How many solutions?
Infinite.
Infinite amount of solutions. The way we say this guy's called parallel lines, right? This guy's called lines coincide. Lines coincide, infinitely many solutions or infinite amount of solutions, whole bunch of them. That's cool. Okay, there's a graphic in the book like that. It looks like this right here. So exactly one solution, infinitely many solutions, and no solution. So this is just a quick little graph. Let's see, this is on page 5. If you guys want to just kind of take a look at it by yourself, this is on 510. I just kind of copied and pasted it. So two lines intersect at a single point. That's cool. Lines coincide is the term where the line is right on top of the other line, and then we have lines are parallel. We're good. Okay. We've got 5 minutes left. Jam, okay, so then let's jam to this one here. We should do the 2 things here. So let's see what happens if we do the elimination method, but we know for sure that this is a no solution case, which means these 2 lines are parallel to each other. What happens when we do elimination?
Well,
So which one do you guys want to?
Multiply the top one by 2, and so then there's just straight up no variables, because they both cancel out.
2, 6, negative 2x plus 4y is equal to 1. So whichever one you're trying to do, if you're trying to get rid of the y's, you would multiply by 2 to get opposites, but then the x's also become opposites. And notice the y values. I'm sorry, the constant values at the end, they're different from one another, huh?
Wait, so we just simplify to add 2 right away.
But then we would get 0 equals.
6. You just want to do it.
No, stop, no.
Yes. Yes.
No, I hate that. Wait a minute. Wait a minute. Stop it.
All right, we do this like this. We say that.
0 is no longer
Yeah.
I love that.
So what we could do is we could
Oh,
just add.
that is.
We can do it.
Could we try to add?
It's not a solution that tries to read.
X plus 3 equals 2y divided by 2.
Wait, 0 equals 7 times. Then that means that 7 equals 0. So 7 is
Do
technically
the
like
subtract 4
infinite,
divided by 2.
because
yeah.
nothing is infinite and 0 is nothing.
Everything divided by 4. Yeah.
Also,
Negative
wait,
1
and
half
most
x.
culture 7 is an unlucky number.
Minus 1 half.
We really have.
Yeah, true, we just did the thing in math, you don't get
So not following. Sorry, no, say again, one more time.
Couldn't we just try to
And
graph
that's
it?
why,
Because-
because 7.
Yeah,
is
that's right, yeah.
number.
So if you were to graph these 2 lines here, we should do that here.
Figured out the number of the void.
Guys, real quick here, look at this. If we were to solve for y over here, subtract 2x from both sides, divide by 4, should give us, let me try to do this all at one spot here. This should be a 2x plus 3. You guys talk to me if that's true.
Totally, yeah. Sure.
If we subtract, minus 3. If we subtract 2x from both sides, then divide through by negative 4. Oh, that'll be a negative, that'll be a 1/2.
You also have to divide through 6, right?
Yeah, and so 6 divided by 2 is a 3 at the end there. Oh, by 4. That's right, by 4. That's what I'm missing. Okay.
Negative keep. Okay, I've connected 2 dots connecting because it's negative capability. Because we are holding both nothing and something in tension at the same time. Stop. So they're left to left. So therefore, it's negative capability, which connects to English. Therefore, this is a modernist mathematical equation.
So wouldn't one of these not solutions, it wouldn't go over here.
Absolutely. So guys, real quick, let's take a look at this here. So slope is the same, right? In order to have parallel lines, the slope has to be the same. But the problem is the y-intercept is different. So in this case, the y-intercept is right here, negative 3/2. On this one, it is a positive 1/4. They are still parallel because the slopes are the same. So really, slopes are the same, y-intercept is different.
It's not the end, it's 7.
Same slope, have a different y-intercept. Okay, the other way. Let's go the other way. What happens if there is, we're gonna do it by the elimination method. There's infinitely many solutions. Which one do you, which variable you want to get rid of? X or Y?
Let's get rid of.
Get rid of
Let's
the Y?
multiply the top part by negative.
-2.
They're not negative 2.
No, negative 2.
Negative 2.
No, positive 2 is.
No,
Oh,
negative,
no.
negative 2,
Oh,
no.
negative 2.
This happens when you get asleep.
The fury.
Don't question me. I know I'm wrong about literally everything but about this. I know what I'm doing. So 0, wait, guys, that means that 0 equals 0.
Oh,
so-
yeah, did not break this
Sorry.
time.
Oh, it equals 7. You already
You
saw
already
it.
did it.
No.
Oh, it is.
0 equals 0.
Well, 0 equals 0 also equals 7.
So it's basically
Everything
equals 0.
Yeah,
7 and there's 0. I mean.
I prefer the UW.
So it's 7 times.
I feel like it's more aesthetic.
Obviously.
Yeah.
Yes.
7
Seven
guys.
times.
No, so we just say that out loud. What is that noise? Yeah.
All right, so what's happening, so as far as what is the solution, infinitely solutions, what's happening graphically is the lines coincide. Good. And notice real quick here, I guess we should do this here. Notice if I were to multiply through by a -1 on top, I get myself this equation.
It's the exact same.
All right,
Wow.
better be, because it produces the same exact line. And next, the fun one.
You, I hate that.
Oh,
I like that.
Oh, I
Okay,
hate
so
it.
wait, it's 2 over
No.
100 around 0, 3 over 100.
Okay, so let's multiply the top one by 0. No, I don't like that. Okay, let's multiply the top one by 0.04, and then multiply the bottom
oh,
one
wow.
by 0.05. Ugh.
Let's see. Raise your hand if you like decimals. Okay, besides Landon, how about this? Let's just multiply this by 100. How come 100?
Then it's not a decimal.
Yes. So we're gonna,
Get those decimals.
you
out of
could
here.
make them fractions, but then you're still gonna multiply it by 100 to get rid of the denominator. So we're doing this one not to get opposites. We're just doing this one just to get rid of decimals. So how about 2x minus 5y is equal to -38? How about a 3x plus 4y is equal to 104? And then you guys tell me what to do next.
Then we're gonna.
Top by 4, bottom by 5. I'll go with that. 8x minus 20y is equal to, anybody help me out? 38 times 4.
100.
152.
Yeah, that sounds right.
Guys, real quick here, how to do this real quick. If you do it on a sheet of paper, look at this real quick here. If you guys do it on a sheet of paper, then we'll do 8 times 4 is 32, right? We carry the 3, right? That's 12, 13, 14, 15, right? If you do it mentally in your head, it's actually easier to do this first, because you know that's going to be 120, right? Because you know you're in the tens place. And then what you do is you had, because you already have 120 mentally there, 32, when you add them together, gets you that right here. So mentally you go from right to left, from left to right. 152, done. Let's go with this one. 15x minus or plus 20y, and this will be 520. $23x, done, and this is, I don't know. Anybody with a calculator can do that here.
It's like.
We have 30
4
seconds left.
Something. No, it's 30 something.
Actually equals 520 over 23.
Say again.
520 over 23. I want to get on my phone.
That's not true.
It's 368,
Oh, what?
right? Because you're doing 520.
No, 520 minus 152 should be 320 something or 3.
I did 520 minus 152, and that's what it got.
What did you, let me see, that's one again? 368.
So then
Okay,
X equals 16, so it's still a whole number.
okay, gotcha. I'll go with it here. X equals how much? 16?
16.
plug it back in, you should get y is equal to.
Exactly.
Yeah, one. Nice. Love that.
I'm gonna go 14. Okay, if you did it correctly, you should have get this one right here at the end. So finish that off. And you guys have 7.2 homework, right? And we are out of here, 1 minute behind schedule here. Have a good Friday.